All right, boys and girls, just in case you weren't paying attention in class, and yeah, that's right, I'm looking at you. Here's another example. So, polynomial long division. First thing we're going to do is we're going to write the powers of what we're dividing in order, and we're going to add placeholders if it's needed. So what I mean is I write those in descending order. There's no x to the 1 power, so I'm going to add that in. So I have all my, so it goes x cubed, x squared, x number. Set it up like a long division. So now I want to think, what can I multiply 2x by that would equal 6x cubed? And that's what's going to go here. Because what I want to do is get something that I can subtract and eliminate the 6x cubed with. It's actually the same thing that the division algorithm uses. So that would have to be a 3x squared. So that's what I would multiply. Make sure I line up the powers. So it's an x squared, so I put it over the x squared, just like you would line up the tens or thousands or hundreds. Same thing here. So now I multiply 3x squared times the binomial I am dividing by. That means I need to distribute. So doing that gives me this, and then I need to subtract that from the polynomial above. So when I'm subtracting, I'm actually going to distribute that negative, and that's going to change all the signs, and then I'm just adding like terms. So I get, those are both negative. Now I'm combining like terms, gives me a negative 4x squared. I bring down the next term and repeat the process. So 2x times a negative 2x will give me a negative 4x squared. Distribute that. Change both the signs. Add, bring down the next term. 2x times a plain old 3. And distribute that. Negate them. Add them. Since it divides evenly, that means 2x plus 3 is a factor. So it would be a root of that polynomial if we were trying to find the roots of this polynomial. Or we could use that to find the root. If it didn't divide evenly, I would just say remainder is whatever the remaining number was. All right, see you tomorrow.